Okay, determining function families from tables. The tables for different functions can tell you which family it belongs to. To test these, you must make sure that your x values are in numeric order before you begin. So numeric order, meaning from least to greatest, going up by ones. Linear functions, they have a common first difference, which we'll do an example of. Quadratic functions, they have a common second difference, which again, we'll do examples of these. And exponential functions have a common ratio. So as you look at a table of values, these are three functions that we can determine without ever having to graph. So let's start with a couple of examples. So we're given a table of values here. We'll start with number 1. Negative 1, 5, 0, 11, 1, 17, 2, 23, and 3, 29. So we want to determine what function family does this table of values represent. So we'll start with the first difference, see if it's a linear function. So when we're talking about first difference, we're looking for what's the difference between each of these points. So from 5 to 11, we add 6. From 11 to 7, we add 6. From 17 to 23, we add 6. And from 23 to 29, we add 6. So this is what we would call a common first difference, which would make it a linear function. Okay. If we were looking for a second difference, we would look, well, what's the difference between these two values and these two values and these two values? And if that's all the same, we would consider it a quadratic function. But you always have to check, is it linear first? If it's not linear, then you can check quadratic. Okay. So let's look at the second one. So as we look here, we can consider the differences again. 30 to 15, we subtract 15. To 7.5, we subtract 7.5. Subtract 3.75, subtract 1.875. So it's not a common first difference. We can check second difference. So this will be adding 7.5, adding 3.75. So I've already determined, I don't even have to do the last one, that it's not a common second difference either. So what we check is the ratio. So when we are checking ratio, you're looking for multiply or divide. So as we go from our first to our second term, we are dividing by 2, or in other words, multiplying by a half. As we go from our second to our third, we're doing the same. We're multiplying by a half. As we go from the third to fourth, again, multiplying by a half. From the fourth to fifth, again, multiplying by a half. So we're just looking at all these y values. So this is what we have. We have a common ratio. So we would consider this an exponential function. And again, what we did up here, this is what we would call the first difference. The second is what we would call the second difference. Since we had a common ratio, that's why we have an exponential function. Okay. All right, 2 more problems here. What I'd like you to do, try both of these on your own. Check first difference, second difference, and ratio, and see if any of them apply, if these would be first or second difference, or if these would be a linear, quadratic, or exponential function. Pause the video, give it a try. Okay, we're back. So if we check here, first checking that first difference, we go up by 8, up by 2, up by 5, and down by 12. Checking second difference, we go down by 6, up by 3, down by 17. Okay. So definitely not second difference, not first difference. As we look at the ratio, 2 times 5 gives us 10. Ooh. 10 times 1.2. So we've already determined our ratio is not the same either. So this is not a linear function, not a quadratic function, not an exponential function. However, It's not one of those three, so it does not mean it's a non-function. Remember, non-functions are when you have multiple x values, multiple inputs going to different outputs, different y values. That's not the case. We have all different x values, so we don't have to worry about it being a non-function. We're just not really sure what type of function it is. So it's still a function, we just don't know what type. It's none of the above. For the first difference, we subtract 1. Second difference, we add 1. Third, we add 3. And fourth, we add 5. So not a common first difference, so it's not first difference. Let's look at second difference. -1 to 1, we add 2. 1 to 3, we add 2. And 3 to 5, we add 2. Nice. So that one would work. We have a common second difference, so this would be a quadratic function.